In Lab 1, we used a basic household object, sticky tape, to demonstrate applications of electrical and gravitational forces. We brought two pieces of charged tape together and observed their interactions. We then applied what we learned in Physics 1 about Newton's laws and what we have recently learned about Coulomb's law to calculate the charge on the two pieces of tape to be 1.1297 e to the negative 8 coulombs. From there, we created a model in GlowScript to demonstrate this experiment using key equations for the electrical force of tape 1 on tape 2 and the gravitational force on tape 2. We took important measurements in our experiment, including the mass and length of each piece of tape. We need to measure the distance between the two pieces when they interact to give us our value for R. I observed that when the two pieces of tape were held horizontally near each other, tape 2 repelled 3 centimeters, or 0.03 meters, above tape 1 and remained motionless. Thus, we know the pieces of tape have the same charge, and we have determined our value for R. When the tape was brought near the negatively charged pen, it was attracted, and therefore we can conclude that the piece of tape is positively charged. An interesting observation in my experiment was that when I held the tapes vertically next to each other, the distance that they repelled depended on whether the sticky side was facing in or out. This could be due to where the electrons are located on the tape, or it could have been due to other unexpected influences, such as slight user error. Now that we've found the distance between the pieces, R, we can move forward with the calculations. I created a free body diagram to represent the forces acting on tape 2. Because the tape is motionless, the electrical force of tape 1 on tape 2 is equal to the force of gravity acting on tape 2. The calculations are shown on the right. Then, these calculations were transferred to the GlowScript model as shown here. When run, the code produces this output with a representation of the free body diagram and the values of the electrical force and charges of each piece of tape. In conclusion, we determined that each piece of tape has an approximately equal positive charge after its interaction with the base tape, and this occurred because electrons from each piece of tape were transferred onto the base tape. Another conclusion I drew from this lab is that using sticky tape is an effective medium to model electrical forces. If the charges of electrons and protons had switched, our observations would remain the same. Like signs would still repel one another and opposite signs would still attract. However, the overall charge of the tape would, in this case, be negative. It is important to minimize handling the tape because when the tape touches your hand, electrons will be transferred and thus the strength of the positive charge of the tape will be reduced. Thanks for listening.